Hello, this is inverse of one-to-one function. We're going to find the table, graph, domain, and range. And this is your teacher, Sir Daz. So, how are we going to find table, graph, domain, and range? We are given two functions here. We're going to complete the table, the graph, the domain, and range of the inverse of the following functions. The first function is 2x plus 1, and we have the condition if x is greater than or equal to minus 3 but less than 3. And we have the second function, which is square root of 4 minus x if x is greater than 0 but less than 4. To find the table, the graph, domain, and the range of the inverse of the functions, we have to find the inverses first. Let's take a look at example number 1. We are given the function of 2x plus 1. Again, if x is greater than or equal to minus 3 but less than 3. First step, we're going to write the function in the form y is equals to function of x. So it becomes y is equals to 2x plus 1. Step 2, we're going to interchange the x and the y variables. X is equals to 2y plus 1, where x becomes y and the y becomes x. Step 3, we're going to solve for y in terms of x. So it becomes x minus 1 equals 2y, and dividing both sides by 1/2, you're going to get x minus 1 over 2. That would be equal to y. So the inverse function would be x minus 1 over 2. So table of values for the function 2x plus 1. So we're given our x's is minus 3, minus 2, minus 1, 0, 1, 2, and 3. Those values are taken from the limitation above, where it says x is greater than or equal to minus 3 but less than 3. Then again, if you're going to put x is equals to minus 3, the value of your function is minus 5. If it is minus 2, then the value of function is minus 3. If x is minus 1, the value of your function is minus 1. And if f is 0, then the value of your function is 1. If your x is 1, then the value of your function is 3. If x is 2, the value of your function is 5. And x is 3, then the value of function is 7. So the x there represent the domain of the function, which if you're going to write in a interval form, that would be close interval minus 3 up to 3 open interval. If you're going to write that one in set builder notation, that would be x is an element of R, where x is greater than or equal to minus 3 but less than 3. How about for the range? So the function of x there represents the range of the function, which in interval form, we can write that one as close interval minus 5 up to 7 open interval. If we're going to write that one in a set builder notation, you have y is an element of R, where y is greater than or equal to minus 5 but less than 7. For example number 1, we are going to find now the table of values of the inverse function, and the inverse function is given as x minus 1 over 2, and then we're going to take x is less than x is greater than or equal to minus 5 but less than 7. So if x is minus 5, then your inverse function is minus 3. If x is minus 3, then the inverse function is minus 2. If your x is minus 1, then your inverse function is minus 1. And if x is 1, then your inverse function is 0. And your inverse function is, your x is 3, then your inverse function is 1. If your x is 5, then your inverse function is 2. And if your x is equals to 7, then your inverse function is 3. Then again, the x there represents the domain of the inverse function. This time, that is the domain of the inverse function, which is in interval form. We can write that one as close interval minus 5, 7, open interval. If we're going to write that one in set builder notation, we have x is an element of R, where x is greater than or equal to -5, but less than 7. And for the inverse function, those values represent the range of the inverse function, which in interval form, we can write that one as close interval -3, 3, open interval. If we're going to write that one in set builder notation, we can write that one as y is an element of R, where y is greater than or equal to -3, but less than 3. Let's take a look and compare the two tables under of domains and ranges. So for the function 2x plus 1, we have that table. And for the inverse function, we have the table. So take a look very closely. Did you notice? The domain of the function is the same as the range of the inverse function. Also, the range of the function is the same as the domain of inverse function. That is because this is the property of inverse of a one-to-one function. That is the graph of example number 1. If you can see, the green one is the line of reflection, and then if you can actually see that one, the green one is where your function and your inverse function will meet. Let's take a look at example number 2. Solving for the inverse function. So that is the square root of 4 minus x. Oh, sorry, that should be number 2, where x is greater than 0, but less than 4. Step 1 again, write the function in the form y is equals to function of x. Y is square root of 4 minus x. Step 2, interchange the x and the y variables. X now becomes y and y becomes x. It becomes x is equals to the square root of 4 minus y. Step 3, solve for y in terms of function of x. Sorry, in terms of x. So you have x squared is equals to 4 minus y by squaring both sides. And then you will get y is equals to x squared minus 4. So the inverse function is 4 minus x squared. Let's take a look at the table of values for the function square root of 4 minus x, where x is greater than 0 but less than 4. So the values of x now is from that range 0 to 0, 1, 2, 3, and 4. If x is 0, then your function, the value of function is 2. When your x is 1, your value of function is square root of 3. When your x is 2, the value of your function is square root of 2. When your x is 3, the value of function is 1. And if x is 4, the value of your function is 0. Again, x represents the domain of the function. In interval form, you can write that one as open interval 0 to 4, open interval. If we're going to write this one in set builder notation, you have x is an element of R, where x is greater than 0 but less than 4. For the function it represents the range of the function, which in interval form it can be written as open interval 0 to open interval. If written in set builder notation, y is an element of R, where y is greater than 0 but less than 2. Now let's take a look at the table of values of the inverse function. Your inverse function is 4 minus x squared, where x now is less than 0 but greater than 2. So you got 0 for your value of x's, 1, square root of 2, square root of 3, and 2. If your x is 0, the value of your inverse function is 4. If it is 1, then the value of your inverse function is 3. If it is square root of 2, the value of your inverse function is 2. And if it is square root of 3, then the value of inverse function is 1. If it is 2, that is 0. X here represents the domain of the inverse function, which in interval form can be written as open interval 0 up to 2, close interval. It could also be written in a set builder notation as x is an element of R where x is greater than 0 but less than 2. For the range, the inverse function represents the range of the inverse function. In interval form, we can write that one as open interval 0 to 4, open interval. If we're going to write that one in set builder notation, y is an element of R where y is greater than 0 but less than 4. We're going to compare the two tables, domain and ranges. So the given function is square root of 4 minus x, and then the inverse function is 4 minus x squared. That is the table for the function. This is the table for the inverse function. Did you notice again? The domain of the function is the same as the range of the inverse function. The range of the function is the same as the domain of the inverse function. Again, that is a property of inverse of a one-to-one function. Here is the graph of the function against the inverse function. You see the blue line there? That is the line of reflection where x is equals to y. This is where your inverse function and your function meet. So the red one is the inverse function and the blue one is the inverse of the function. Oh, sorry, the red one is the inverse function while the blue one is the function. If you can see, the end of those graphs are actually hollow circle to indicate that it is not included.